Good morning, welcome back. We are going to finish our notes on section 7.5 today. So when we did the first half of the notes, we mostly focused on what a recursive rule was, how to use the recursive rule to find the sequence, and then we went over how to use a sequence to create a rule. So today we're going to just kind of use some application with this. So the first thing that we're going to go over is an iteration. So an iteration is the repeated composition of a function within itself. So the result of one iteration would be f of x, which we had done back when we did some composite functions in an earlier chapter. And two iterations would be f of x. So essentially you're finding f of x, and then you're taking that solution and you're inputting it into that same function again. So we're going to actually go through finding the first three iterates of a function. So it sounds a little bit more confusing than it is. So what's happening here is that they're giving us that initial value to start with so that we can then go through and find the next three iterations. So if we're using the function f of x equals 5x minus 3, and the first number that we're going to substitute in is 1 for x sub 0. So if I'm going to do f of x sub 0 equals 5 times 1 minus 3, and that's going to give me 2. So this would be my first iterate here. So this is now my x sub 1, or my first iteration there would be 2. So then if I plug that in, I am now plugging in the 2 for the x. So 5 times 2 is 10, and 10 minus 3 is 7. So that's my second iterate. And then if I want to do that one more time to find the third one, 5 times 7, oops, my pen got a little wonky there, minus 3, we have 35 minus 3, which is 32. So our first three iterations, or iterates, would be 2, 7, and 32. So now for number 2, we're going to this time start with the value of negative 1. So to find my first iterate here, that should be, all right, so f of x sub 0, we're putting in a negative 1 for my x, squaring it, and then minus 5. So that's going to give us a positive 1 minus 5, which is negative 4. Then when we go to do our next iteration, we will plug in the negative 4, and that's what will be squared. So negative 4 squared is positive 16, and then we subtract 5 and we get 11. And then we go through one more iteration, and we're going to do 11 squared, which is 121, minus the 5, which is 116. So it's not so bad. You're just substituting something in, taking the answer, substituting it in again, taking that answer, and you just repeat that process as many times as needed from the directions. So now when we go down to numbers 3 and 4, same thing. This one's just a little bit different because it's a fraction. So if I'm going to do my first iteration here, I'm going to plug in the 3. So it's going to be 3 squared minus 3 over 3. So that's going to give me a 9 minus 3 on the top, which is 6. And 6 divided by 3 is 2. So that would be my first iterate. So now I'm going to do the next one. This time I'm plugging in a 2, so it's going to be 2 squared minus 3 in the numerator over 2. That's going to give me 4 minus 3 on the top, and I end up with 1/2. And then I'm going to do that one more time. So this time I'm putting in a 1/2, so 1/2 squared minus 3 over 1/2. Now 1/2 squared is actually 1/4, and 1/4 minus 3 over 1/2. So if I'm doing this the long way, right, without a calculator, I'd have to make this a 4 and this a 12. So 1/4 minus 12/4 would be negative 11/4. And I'm dividing that by 1/2, which means I'm multiplying it by 2. And my answer would be negative 11 over 2, or negative 5.5, or negative 5.5 if you used a calculator and got a decimal. And then my last one here, we're starting with the 2. So to find my first iteration there, I'm going to do 2 squared minus 2 minus 2. Now just make sure you're using your order of operations or your PEMDAS when you solve these. So 2 squared is 4. 4 minus 2 is 2, and 2 minus 2 is 0. Then we're going to plug in the 0. So 0 squared minus 0 minus 2. Well, 0 squared is 0, 0 minus 0 is 0, and then we have that negative 2 left, so that's all we're ended up with there. And now we're going to plug in that negative 2, so negative 2 squared minus negative 2 minus 2. Well, negative 2 squared is positive 4. When you subtract a negative, it becomes addition, so 4 plus 2 is 6, and 6 minus 2 is back to 4 again. So those are our 3 iterates for that one. Okay, so where are iterates used in real life? So a classic example is with a loan and something that you pay back every month or so. So the first example we're going to go over here is this mortgage example. So this is like a classic iteration. So what happens is you have a mortgage, right? Or a car loan or whatever it is. And that's going to be some starting amount. So in this case, let's say we're taking out a mortgage for $140,000. Now, on the first of each month, the bank is going to charge you 0.5% interest. And then on the 15th of the month, the family makes a payment of $840. So what's going to happen is your interest, while the first month it's on 140,000, the next month it's going to be on less because every month you're making a payment. So your balance is decreasing. And so the interest that you're paying is going to also decrease because it's a percentage of a smaller amount as it goes down, which is why with typical loans, whether it be a car loan or a house mortgage, something like that, in the beginning, you're paying much more interest because your payment typically stays the same. So a larger portion of that payment is interest in the beginning. And as you go through the loan, a higher portion of that payment goes to the principal and less of it goes to interest. So we're going to use a recursive rule because we're constantly basing that interest off the next amount, right? So the first month, we're basing that interest off the 140, but the next month, it's going to be based on, probably 139,000 and change or whatever. So you can't just write a formula where you're plugging in what month it is. So you have to use a recursive rule in this situation because you're constantly adjusting that amount of interest that you're being charged based off of the new principal. And then we're going to find the balance after 3 months. So that's kind of important because we want to know at the end of the third month. So sometimes with these problems, you have to be careful because it's like, are we figuring out at the beginning of the month or the end of the month? Because at the end or after the month has finished, things have happened during that month. So when that happens, since I'm concerned about what's happening at the end of the month, I'm going to make my starting information be a sub-zero. So my A sub-zero is going to be that 140,000. And then we know the rate, the interest rate is 0.5%, which is actually 0.005. So if you think about it, when we're talking about interest, how do you calculate interest? Well, you calculate interest by multiplying by a percentage, right? So if you're multiplying by a percentage, that's going to be a geometric formula because there's a multiple involved. It's not like you're adding something on each month or whatever. So that's why we're looking for the R, the common ratio, and then of course our A sub-zero. Now I'm going to attempt to pull up my calculator without closing this out. So hopefully I am successful in doing that. Let's see if I can do that real quick. Minimize here. Hopefully that will load because I'm going to need that calculator for this. Okay, so it looks like it's going to pull up. Okay, so we're going to be figuring out a geometric recursive rule here. And then we're going to play around with it a little bit, right? So the basic point here is that we're starting out with an initial amount. at the beginning of the first month, right? The beginning of the loan, which is $140,000, and our interest rate staying constant throughout the loan. It's that 5.5%, which is 0.005. So if you remember back to our notes or actually earlier in these notes, right? So I can actually scroll back just as a quick refresher. The geometric sequence here for recursive is A sub n equals R times A sub n minus 1. So that's what we're going to be using. Okay, so we are going to start out with A sub n equals the R value, which is 0.005, right, times A sub n minus 1. Now, this is sort of just like a work in progress. We're going to be basing it off of that. It's not that simple because this number is not going to be increasing, right? It's going to be decreasing. So if we are going, so like, let's just think about this for a minute. If our mortgage is $140,000 and the bank charges us 0.5% interest, what are we going to be paying now, or what are we going to be owing now, right? So if I take a look at my calculator, for example, if I were to figure out 140,000, oops, I think I put too many zeros on there. Oops, let me retry that. Hold on. 140,000. Okay, so 140,000 times 0.005 means in the first month I'm going to owe $700 of interest. Sorry. So now, what I want to figure out now, though, is not how much interest am I paying, but how much does this total amount go up to? So just like when you're figuring out tax and your total bill at a store, it's the same idea. So we figured out the interest, which is $700, but then we would need to add that back on to that $140. And that would make our grand total before we make that first payment of $140,700, let's say. Okay, now this is just an example that I'm just trying to show you how it works, just because when we do this, we're doing two steps of math, right? First, we're multiplying to figure out what the interest is, and then we're adding the interest back on. So instead of doing it in two steps, and I've done this before when we've done problems with like tax and stuff, if you take that original amount and you multiply it by 1.005, what it will do is it'll calculate that interest and add it back on in one step. So that's going to be useful here. So if we take a look at this, even though my R value is 0.005, that's not what we're going to be multiplying to that 140, right? We're going to be multiplying to that 140 1.005. And that's the common mistake that people make. They forget to put that 1 in there. And if you don't, then you're going to have to like somehow incorporate that addition back into there. And it's just more complicated. So if you can make it 1.005 when you input it in, because what's going to happen here, the A sub n minus 1 is going to be the amount. Like in this case, it would be 140. You're going to be multiplying that to that 1.005, right? Now, the only catch here is we are going to be making payments, right? So yes, we are going to be charged the interest rate of whatever that amount is, but we are also going to be making a payment. So we want to include that as well. So we're going to be subtracting $840 from that total amount. So that's going to be factored in. Okay, so now this A sub 0 is the 140. Okay, now what's happening first? On the first of each month, the bank charges 0.5% interest, and on the 15th, the family makes a payment. So let's say, obviously this is a little tricky depending on when you start. So I'm going to just say that, let's say it started at the first of the month. They're not going to charge you interest the day you get the loan. So we'll say that A sub 1 We'll put that in. And if I'm putting that in there, that we'll just say that if I have a sub 1 here, I want to calculate what that is. So I'm going to do 1.005 times a sub 0 minus 840. Now, when you do that on your calculator, you're obviously going to be putting in 140,000 minus 840. Okay, so now this is going to calculate the interest first and then subtract the payment. If you wanted to start it the other way, it's not really clear which way it would work. But since the first of the month comes first, we're going to do it as if the interest is added first. So then when you do this calculation on your calculator, you have the 1.005 times 140,000, and then you're going to subtract 840. And that's going to tell you how much you have left on your loan. So 139,860. So that is the first iteration. So after 1 month, this is how much you would owe after you've had the interest added on and the payment made. So now what about after 2 months? So you're still going to use your 1.005, but now you're on a sub 1 because n minus 1. So that would be that. And then you're still minusing 840. That's not going to change. So now when we put in, this time we're taking that 139,860, and that's our input. And we're working it out from there. So we would do 1.005 times 139,860 minus 840, because that's our payment. And we have 139,719.30. 139,719.30. And then if we want to know after 1 more month, we could do this iteration 1 more time. So 1.005 times 139,719.30 minus 840. Now, since I still have my 139,719.30 in my calculator, I'm just going to multiply that by 1.005 and then subtract the 840. And then I get my 139,577.89, or I guess I would round to 90. So 139,577.90. Now, if you wanted to do a bunch of iterations, you could go to your y equals, and you could type in, I'm trying to think, I don't know if I can do the n minus 1. There's probably a way, but I'm not quite sure, so I'm going to skip that for now. All right, so anyway, that's how you would get your different iterations, and we'll go from there. All right, so now we're going to try another example. This one is a mosquito population in a controlled laboratory condition is estimated to be about 500. Each day, an additional 100 mosquitoes are hatched. The population also declines by 85% every day from a pesticide or other natural causes. So use a recursive rule for the number of mosquitoes at the start of the nth day. So this time we're looking for the start of the nth day. So last time we used a sub 0 as like that starting point because we were like at the end of 1 month, that was a sub 1. So if we could just scroll back here for a second. So my 140 was a sub 0 because that was the beginning of the first month. And then I used a sub 1, a sub 2, and a sub 3 to indicate the ends of month 1, the end of month 2, the end of month 3. Because this one, we're concerning ourselves with the beginning of each month just to kind of keep the numbers straight, or the beginning of each day, I'm going to start out with a sub 1 instead of a sub 0. So for example, like the beginning of day 1 would be n value of 1. And the number of mosquitoes will be a sub 1. Okay. The beginning of day 2 will be n value of 2. The beginning of day 3 will be the n value of 3. And then we're going to do 4 and 5. Okay. Whereas the last problem, we were looking at the ends of the month, which is why I did the initial value as a sub 0 instead of a sub 1. Okay. So my a sub 1 is 500. I'm starting with 500 mosquitoes. Now this time there's a decline. The percentage is a decrease. So we don't need to do the 1 point whatever, because that would be if it was increasing. So when it's decreasing, if it's decreasing by something, and you're trying to find out how many are left. So if the population is decreasing by 85%, how many or what percentage of mosquitoes are left? 15%. So that's what we want to put here for the R value. So, I mean, yeah, it's decreasing by the 85, but you want to use 0.15 to show like how many do you still have. So if I said like, how many mosquitoes do you have left after one day, and you started with 500, you would do 500. You could figure out 85% and then subtract it, or to do it in one step versus two, you just say, okay, well, what's 15% of 500? So to figure out my little formula here, I'm going to use, again, my R value times my A sub n minus 1. Now, if I am going to start out with this 5, and then I'm going to add 500 new ones each day, right? So for my first one, 0.15 times, I'm putting in that initial value there, 500. To start with. And 15, this is where your calculator is going to come in. So you're going to do 0.15, 0.15 times the 500. Okay. So at the end of the day, you have 75 of the original mosquitoes left, plus you hatch 100 more. So you have 175. Now at the beginning of day 1, we had 500. So day 2, at the beginning of day 2, we have 175, like that. So a sub 1 was already given to us, so we just had to start out finding a sub 2. So now we're going to use the 175. So we're going to do 0.15 times 175 plus 100. So actually, I'm just going to leave that 175 there, times 0.15. So that's 26.25 plus 100. Now, obviously, you can't have a decimal of a mosquito, so that's just going to be 126. And now let's see what we have at the beginning. That was the beginning of day 3. So now the beginning of day 4, we're only going to have 15% of those left, plus another 100. And that's going to round to about 119. Now, let's say we just put in the 126. 126 times 0.15 plus 100. You still have pretty close to the same number, so 119. And then one more time, you want to know how many you have at the beginning of day 5. So 119 times 0.15 plus 100. And that's 117.9. We're going to round that to 118. Okay, so if you remember when we did the sum formula for an infinite geometric series, it approaches or kind of gets closer to something. That's kind of similar here. You're noticing it's starting to level off. So even though a large portion of those original mosquitoes didn't survive, once we get to day 4 and 5, we see that the number of mosquitoes is pretty much leveling off. Okay. All right, a warehouse has an initial stock of 4,800 units of a product. So that would be like that initial amount, right? So for now, we'll say it's a sub 0, maybe a sub 1, depending on what they're asking us. Each week, the warehouse ships out 50% of the product units and receives 2,100 new units of the product from its supplier. Write a recursive rule for the number of product units that the warehouse has at the beginning of the nth week. So since we're doing the beginning, then we'll start this out with a sub 1. So the beginning of the first week, they have 4,800, right? Now, the R value here is just going to be 0.5 because if they're shipping out 50%, they still have 50%. So typically your R value is like, what do you still have? So if I take every number and I multiply it by 1/2 and I get the next number, multiply it by 0.5, you're still maintaining 50%. So the last problem, we were only maintaining 15% because we were losing 85. Here we're losing 50%. We still have 50%. So that's why the R value is the same. So now the A sub n will equal 0.50 times the A sub n minus 1. But in this particular problem, they're receiving 2,100 new units of product after each week. So, or at the end of each week, or however that works. Okay. Okay, so because we want to know, it says write a recursive rule for the number of product units the warehouse has at the beginning of the nth week. And then it says how many product units does the warehouse have at the beginning of the 4th week, right? So at the beginning of week 1, we know that there's 4,800. So that's why when my n is 1, my A sub n is going to really be A sub 1, right? So that's why we're making A sub 1 4,800. So when the beginning of week 2, that's going to be A sub 2. The beginning of week 3 will be A sub 3. The beginning of week 4 will be A sub 4, right? So this is already the part with the n that they asked us for. So how many product units does the warehouse have at the beginning of the fourth week? We just have to do that iteration now. So we're using this formula, and we're just iterating it 3 times to fill those in. So if I want to know A sub 2, the beginning of the 2nd week, 2 minus 1, right, is really the A sub 1. And we already know the A sub 1 is 4,800. So what's 50% of 4,800 plus 2,100? Well, 50% of 4,800 is 2,400 plus 2,100. So that would be 4,500, right? Then you're going to do that iteration for the next one. So the beginning of the 3rd week. So 0.50 times the 4,500 we just got plus 2,100. And you can do that on your calculator and you should get 4,350. And then for the 4th week, one more iteration there. We're going to put in the 4,350. So half of that plus the 2,100, and we get 4,275 if I have my calculations correct over here. All right, and that's pretty much how iterations work. Those are just a few like actual examples of where they could be used. I think the mortgage loan one particularly is, realistic and something that most people will deal with. So it's interesting to see how they kind of figure that out. And it actually is a recursive rule, believe it or not. And that's about it. So we're finished with this chapter. Monday, I will be posting some review to work on. I will probably also have a meetup scheduled in case anybody wants to check in and have any questions. And then the test will be on Tuesday. And then we'll move on to the next topic from there. Just keep in mind, guys, the marking period is officially over. So if there's any work you are missing, please get that to me ASAP so I can get that those grades finalized. And that's it. Have a great weekend.